All right, let's talk about a single number that can totally change how you look at your data. We're diving into something called the standard error. Now, it might sound a little technical, but stick with me because it's super important. We're going to break down what it is, why you should care, and, best of all, how to calculate it in seconds, right inside Excel. So let's set the scene. You've done the hard work. You've collected some data, maybe from a survey or an experiment you ran. But here's the thing. It's just a sample, right? A tiny piece of a much bigger puzzle. So the huge question that's always hanging in the air is, how much can you really trust this little snapshot? Does it actually tell you the whole story?
Well, the answer to that big question, that whole "can I trust this" thing, it comes down to one simple but really powerful statistic: the standard error.
Okay, so what is this thing exactly? In simple terms, the standard error is basically a report card for your sample's average. It tells you how close your sample's average is likely to be to the real average of the entire population you're studying. Think of it like a built-in confidence meter for your data.
Let's make this real. Forget the jargon for a second. Picture a big school, say 500 students, and your job is to figure out their average height. Now, measuring all 500 kids? No way. You don't have time for that. So you do the logical thing, right? You grab a sample. Let's say you just measure 30 students. But here's where it gets tricky. That first group of 30 students you measured, maybe their average height is 160 centimeters. But what happens if you go back and pick a completely different group of 30? Well, their average might come out to something like 152 centimeters. See the problem? Every sample you take could give you a slightly different answer.
And that is where standard error comes in to save the day. It's brilliant, really. It looks at all that potential bouncing around, all that variation, and boils it down to one number. That one number tells you just how much you can expect those sample averages to differ from the actual, true average of all 500 students.
So what does this number actually mean for you? It's simple. If you get a high standard error, that's a red flag. It means your data points are all over the place, and your sample probably isn't a great representation. But a low standard error, that's the goal. That's the good stuff. It means your data is nice and tight, and your sample average is probably spot on. Just remember this: smaller is always, always better.
Okay, so I think we've got a good handle on what standard error is and why it's so crucial. The next logical question is, how in the world do we calculate it? Well, the good news is it's super easy. Let's fire up Excel and get to it.
First things first, you've got to have your data lined up in a column. Just a simple single column. For our little walkthrough here, we're just going to use a small sample of 10 measurements to keep things clear. Believe it or not, this whole calculation comes down to just 3 ridiculously simple steps. 1, get the standard deviation. 2, find the square root of how many data points we have. And 3, divide the first number by the second. That's literally it. Let's do it together.
All right, step 1. We're going to use one of Excel's built-in formulas for this. Now listen up, because this part is key. You need to use the formula equals stdev.s. See that .s at the end? That's super important. It stands for sample, which is what we have. So you just type that into a cell, highlight your data, and boom, hit enter. Step 1, done.
Okay, on to step 2. We need the square root of our sample size. Again, Excel has our back. We can use the count function to figure out how many data points we have. In this case, it'll tell us 10. Then we just wrap that in the sqrt function to get the square root. Easy peasy.
And here we are, the final step, step 3. And it's the easiest one of all. You just click on a new cell, take that standard deviation value we calculated, and divide it by the square root number we just got. The result? That number right there, that's your standard error.
But wait, there's more. If you're like me and you love a good shortcut, you can actually do all of that in one single step. You can combine everything into one master formula. Just type equals stdev.s for your data, a slash for divide, and then sqrt with the count of your data inside it. One formula, one cell, and you get the final answer instantly. It's a game changer.
So, let's bring this all home. What's the big deal here? We're not just playing with formulas for fun. This one number, this standard error, it's all about confidence. It's the number that lets you stand behind your analysis. It's your proof that you can trust the story your data is telling you.
All right, so let's do a super quick recap. First, standard error is your go-to for measuring how accurate your sample is. Second, and this is the big one, a smaller error is what you're shooting for. It means your sample is more reliable. Third, it's the key to understanding the variability in your data.
And finally, as we just saw, Excel makes it totally painless.
And really, that's all there is to it. We've covered the why, we've covered the how, so I'll leave you with this one thought. Now that you have this tool, now that you can actually measure the error and put a number on your confidence, what amazing story is your data waiting to tell you?